All right, hello and welcome to AWS Made Easy. This is our generative AI slash Bedrock Hackathon number 2. I'm Stephen Barr. Rahul is out today. I'm joined by Harsh Arya, who joined us last week. Really good to have you, Harsh. Thank you for being here. How have you been? How's your week been?
Uh, Great, awesome week. Thanks, Stephen. Thanks for your warm introduction. It has been a very awesome week. There is a lot of learning that has been happening across the entire days.
What have you been working on that you can share?
Yeah, so primarily I am quite fascinated by the two techs, AWS and LLM. And when they two got combined, they become very, very powerful tech to solve all the problems.
It's I'm a fly on the wall in some of the chat groups that you're in. It's really exciting just seeing the discussions that are going on within the organization and the projects that you're working on. It's really exciting.
Thanks, Stephen.
Wow. And so yeah, thank you for taking time. I know it is your Friday evening, so yeah, thank you for taking the time. Let's see.
No problem. It's always an honor to be on this podcast.
Oh, thank you. I wanted to start with a little bit of news that I saw. Let's put this on screen. It's kind of fun to get warmed up with some of the. I mean, AI is everywhere, right? It's not just in the tech news. It's in the general news. It's in the general culture. We're all thinking about it. It's it's really interesting. I feel like it's this moment where you see all this technology that was science fiction, right? Whether it's
Mhm.
talking naturally to a computer, asking it questions like in Star Trek when they're on the bridge of the Enterprise, they're just talking to the computer, and the
Yes,
computer. I feel like we are putting together the building blocks of what will eventually be that technology,
definitely.
or even yeah. I've definitely seen that a lot. And okay, let me share this article. Let me put this on screen. This is a Wall Street Journal article. And I'm really interested in your take on this, and it really explains something that we were talking about the other day. It's saying how the best AI imitates children. Random exploration
Okay.
is the key to early learning in both cases. And so last week, just to kind of as a refresher, and let me put this link here in the comments. For everyone on LinkedIn, on YouTube, on Twitch, please say hello. Say where, maybe say what you're thinking about AI, what you're hoping to get out of AI over the next month or two. That would be great. Definitely love your comments in the audience. And yeah, I've posted the article. Hopefully, you have enough free WSJ access to see this one. It is paywalled. So let's go to the article. We were talking last week about temperature in AI. And so, Harsh, you were
Yes.
saying that temperature was the randomness of the model, right? How much it will
Yes.
explore. So, could we kind of review that for people who may be tuning in for the first time? So, what's a temperature in an AI model?
So, from the user's perspective, temperature can be considered as a order of entropy into the system. So, as we learned in the science, the universe has a basic law of entropy, basic nature of chaos in the system. How much they will go in some direction, and how much velocity, and how far they will go into a particular aspect. So, temperature is kind of a it is a notion. It is the same term that has been used from the science perspective. So, in a science, in a regular physics, we see temperature as the energy that is contained in the particles. So it is like the same way. So higher the temperature, higher the energy that will be contained in an LLM. So if you provide it more than one, it will be very high entropy, much more creative, will explore much more tokens, will go through the paths which were less probable previously, but now more probable.
Well, I really like that phrase, chaos and more exploration. And so this is it goes here. What temperature is best? And then it says an AI algorithm will start out hot, learning in a more wide-ranging, random way. And so it describes kids at an airport, and they're running up to the
Yes.
window, they're looking at things, they're behaving in a chaotic way. I think I'm a little bit older. I have kids, and we're traveling with them. Yeah, there's a lot more chaos, but that's how
Yes.
they learn. That's how they explore. That's how they figure out the world around them. Whereas, if you and I go through the airport, we're just trying to have the lowest stress possible, being efficient. We're not running around and touching everything and looking at everything. We're much more focused. And so I like that idea of hot as the child's curiosity, where it explores the solution space. But then as the AI models learn, and just like we learn, right, some of our curious explorations have good outcomes and some have bad ones. Later it matures and it kind of knows those paths, but it comes at the expense of creativity, right? And that's why we say, I wish we had the creativity of a child, but with the experience of an adult. But it's hard to have both, right? You can't have this hot cold model.
Yes, that reminds me of the old age AI systems where there is an approach which is called exploration versus exploitation. So either your model will explore all the new paths. For example, if you are playing chess with an AI agent, would it like to explore all the new combinations? Or if he has known that this kind of path usually leads to better results, should he go deeper into that path? So this kind of strategy is actually very, very similar to the how the temperature works. So when the model starts learning out, they do know nothing. Their existing weights and biases holds no values. So because they are just a blank slate. So at that time, we are going into an exploration strategy. So we are exploring out all the paths. We are learning out at a very fast pace. We are rewriting a lot of our model weights and biases. So it's like a child who is just tuning his neurons with all new kinds of question. Why is watermelon sweet? Where does this light coming from? Why is this butterfly flying here? All those kinds of curious questions. You give. Just a few days, I was seeing a video where a parent gives the uh, uh, child something, a question like, or every material in the world is made up of atoms. So then the child starts with a whole lot of questions. Is this table made of atoms? Is this ball made of atoms? Is this air made of atoms? Is the sound that I'm hearing made of atoms? So all those kinds of curious questions that is present in the child, which you can also call as a hot model, where there is a lot of chaos and entropy and a lot of opportunity to learn. So that model starts from that way, and then slowly when they starts learning, their weights and biases that they have learned becomes precious, because they have now done calculations. They have now realized that yes, the earth revolves around the sun. After some time they will also learn that sun also moves. So that's a separate story. But once the kid has started learning some facts and figures, they start being solidified into his brain. Similarly, once the model starts learning weights and biases over the period of multiple iterations, in mid the weights and biases will start keep solidifying. So we do it like this. We start with a higher learning rate where whatever we have is of no value. So just rewrite it whatever way you want. But as we move towards the end, our weights and biases starts holding value. They have realized something, so they go into a cold annealing model where they don't move too much and try to encompass whatever their information is, maybe fine tune it out slightly, but not to disturb too much.
So is there a notion in AI of, I think that the trajectory is to have a lower and lower temperature, but do you ever want to almost reset and say, okay, I want to have a look at the
Yes,
world
definitely. Yes,
through a child's eyes again?
yes, definitely. As the thing that you mentioned, the childs are more curious. So if you look at from different perspectives, childs are also more creative. They are very good artists. Even a very small kid of age 7 or 8, they will draw beautiful imaginations, beautiful pictures, which as our adult mind would not want to draw. So, in that sense, if we want our model to be more explorative, more creative, even though after they have learned something out, but we don't want to kill their creativity. So, for example, let's come up with a real world example. If I have a use case where I have to spawn new stories for my readers, right?
Mm-hmm.
So, if my temperature is low, the AI will always throw same type of stories. I remember there was an experiment that was done on the LLM models. So it keeps spawning kid stories of childs being scared of sliders, The child being scared of strangers. So every time it asks for a story, 20% of the time it comes with all of these same things. Child being scared of rights and others. So the way so they have to increase the temperature, they have to include a lot of randomization in the model and to force model to think in some other directions which were not present in their training data set. This is actually a very, very powerful point that we have raised out. If we look at our early AI, especially in the mid of around 2011 to 2015, with the advent of the popularity of the neural networks, uh, we have a tendency of getting the same results on the data we have trained. So let's say, for example, if we have trained on cats and dogs, and if we give him the picture of elephant, he will not be able to understand that it is not a cat and dog. It will misproportionate it out. So the early models were very, very specific to the training set that we are giving. But these models, large language models, have been trained on such a vast variety of data that they can do a lot of stuff for which they are not being trained. They were able to determine all those hidden relationships between the data, which allows them to do a lot of new things that was not present. So in a sense, they creates a world, a model of the world. So this is the world, this is the word rich, this is the word poor, this is the bird boy, this is the bird girl. So they creates an entire world around these words and tokens, numbers. So so we can introduce so there can be a ton of requirements where we want model to be as creative as possible, but after a certain learning set. So it cannot go rogue, so it cannot say anything non-logical, but at the same time it should have enough creativity to come up with certain answers.
Within later, maybe in certain regulated industries like insurance or banking, right? You just want it to make the most boring, straightforward prediction it
Yes.
can, and that's where that temperature goes way down.
Yes.
Let's see. Just going back to the article for a second. Yeah, this is which temperature is best, and it went to that analogy what we said, simulated annealing, right? And it said this is from metallurgy, where you heat up the metal red hot and then let it cool, and it becomes more resilient. AI algorithms
Yes.
start out hot, learning more wide-ranging, random way, trying lots of unlikely possibilities, and then gradually cools down and settles on the most likely options. I like this. Digital annealing
Yes.
helps get the right balance between creativity and plausibility, exploration, and exploitation. And like you said, depending on
Yes.
the context, that's going to be different. Whether you are, if you are using AI in an insurance setting to predict, a car crash damage amount versus,
Yes.
I don't know, something like write a story where you want that creativity and you want that exploration. You don't just want it to be afraid of spiders every single time.
Yes.
Well, cool. Well, I've put that article in the chat, so have a look at that. I wanted to highlight another resource for our community. Let me see if I can get this on the screen. This is, I'll put the URL. This was put together by Brooke Jameson. It is called How to Learn Generative AI from Scratch. So Brooke is a developer advocate with AWS, and she used to be a machine learning hero. She puts out a lot of good content, so follow her on LinkedIn. All of her social is down here. But she put together this great learning AI from scratch. I like this. This what do you call it? This visualization on how it feels like to learn AI. Right? You watch a few AI movies, and you think, okay, I've got this, and then you try to put it to practice, goes to the bottom, and then it goes. Your knowledge increases as you actually gain that practical experience. So I really like that idea, and Brooke has a very humorous delivery of things. She gives you there's a lot of good here, a lot of good links. It's a very thorough guide, so have a look. She put together some YouTube videos on the topic. So that is learn generative AI from scratch. Let's see, other one that I want to review. I was looking at the what's new for Bedrock. I'll put this in the channel. This is the AWS what's new section. Let's put that in the link. And Harsh, like you said, we the generative Bedrock was not available in all regions. But
Yes.
since we had our last hackathon, we've got an announcement of Bedrock being available in Asia Pacific.
Great. And they have, I think, nearly make available all the models that they have. So people who were previously worried about their data going outside of their country may now start using these new regions too.
Yeah. I guess in terms of latency, so you're in India, so this would
Mhm.
be fairly closer than US East or US West, right?
Yes. Yes. Yes, definitely. However, in case of LLMs, usually network is not the bottleneck of latency.
Mm-hmm.
Usually the computation that they do is very, very slow in terms of the data that they can transfer over the network. So I would not recommend moving a region because of the network speed, but based on the data privacy.
So it's more like where your data already is, right? If you have
Yes.
terabytes of good data in EBS volumes that are sitting in a region somewhere, that's going to
Yes.
cost money to transfer it. Um,
Yes.
so you might as well minimize that transfer cost. Now, one approach is keep everything in US East. Many folks
Yes.
do that, and that's a pretty reasonable approach, right? That's like the key region. Um,
Yes.
but it's good to see that there's now 3 regions where there's full Bedrock support, and I think there's definitely going to be more coming. So we'll keep an eye out for that on the what's new. Other what's new, this SageMaker Canvas. I haven't had a chance to look at this one in too much detail, but there's a SageMaker Canvas, and it's talking about accessing and evaluating foundation models to generate and summarize content. Let's see. Do you use
Uh,
SageMaker Canvas much?
Not much, but SageMaker is also a very good service, slightly different from the ideology of Bedrock, but uh, but there are a lot of open source code models available in the market. Not all of them are going to be available as a Bedrock unit, but if you want to use them, you can directly import many of such foundational models in SageMaker.
Got it. Okay. And so let's see. Looking at their announcement, announced on October 5th, customers can evaluate and access foundation. Oh yeah, that's the ready to use models to include foundations. Well, okay, so that's what you're saying. There's the ready to use models, and then now those
Yes.
ready to use models include foundation models. So here's the other models: Falcon, MPT.
Yeah.
That's
Yes.
really cool.
So I believe AWS has done some partnership with Hugging Face. So most of the models that they have are directly supported into AWS SageMaker.
Let's see. I'll look up Hugging Face. Hugging Face. This is Hugging Face. This is another repository of models.
Yes,
Would you say? Yeah,
it's kind of a open source way to it's acts like a GitHub for models.
got it. And data.
Yes, model and data sets both.
Well, neat. Let's see. I got one more story I wanted to look at, just seeing if you had seen this one. Spotify is announcing AI playlists, uh, which is kind of cool. I mean, I'm a Spotify user, so I think what this is looking for is you're going to have more detailed search, right? So it's not just. Um, I'd imagine most of the playlists before were using matrix completion, those sort of algorithms, but now we can look at give me I don't know, sappy 70s power ballads or something like that, or 80s power
Yes,
ballads, and give it much more um, specific criteria for building a playlist that can look at these um, higher level ideas. And so I guess this
yeah.
comes down to its ability to create embeddings out of songs. Would you say is what powers
Uh,
this?
I doubt they are using embeddings. I have to go through in detail. But the one thing that LLM has enabled is it is changing the interface we are communicating with apps. So previously, let's say before the advent of LLM, even if such a software exists, the way you would interact is You would select few genres that you want. You will select how long you want your playlist to be. You will select the year of which you want. You will select the artist you want, and all of these things you will be do. But now with the advent of LLMs, you can convey the information into a much more friendly manner. Like you will tell to me that I want some maybe happy music, joyous music for my celebration. You can just write that amount. You need not to identify the artist. You need not to identify the genre. You need not to identify the ES. You can convey your information in the way that you understand to the machine. So it has bridged that particular gap. Regarding these AI playlists, uh, are they only generating the playlist from existing songs, or they are also generating some kind of a new songs?
Well, I think it's more. Let's see. I want to see what the it's a okay. Get playlist based on your prompt. So I think it's existing songs, but what it's saying is you can ask the Spotify AI to create a very specific playlist using a textual prompt.
Got it.
So I think you could say things like what is it called? Music of early rock bands that went on to become much more successful later in their careers. Give me their first playlist of first albums, things
Great.
like that. I'm really curious to see what I wish they gave some example prompts in this article to see. Let's see. Yeah, they're showing
I think in the tube, can you open this X post? Yeah,
right
embedding.
here.
Yes, this one. Yeah. So 20 your sound capsule,
No, this is
advanced
AI.
playlist generation tools. Okay. We have to
Yeah,
maybe try out and see how good it is.
yeah. I'm really curious to see this because it's also highlighting, and it almost worked on me, right? It says AI, so it grabs my attention, but to see, okay, is it going to add value? Is it going to be useful? There's certainly a lot of companies who are attaching AI to everything, whether it's a good fit or not. So I want to
Yes,
see,
I'm
is this
amazed by this entire movement, which has come into just a year. And nearly all the products which are new, old, they have this one Gen AI thing in their product, maybe small, maybe big, but it is there just in their product. They are making releases. Uh, you can see any product like Postman, everything, every product which is related to developer cycle, which is related to any e-commerce website, which is related to anything. They are always all coming up with this small Gen AI thing in this.
now? What would be interesting? So say if you had um, Postman using Gen AI, say, and you also had it in your VS Code, and
Yes.
you could somehow say, give me the Postman post request, or give me a post request to test this function which is in VS Code. That would be
Yes.
cool if somehow they had a shared context.
Yes. I think not in the same way, but Postman Gen AI solution achieves something around it. So they allow you to write automatic test cases for the API endpoints that you have. So you give them API endpoints, you give them OpenAPI, and they will generate tons of test cases, API test cases for them out of the box.
So the days of painstakingly creating YAML files for Swagger or something that might be over
Yeah,
to do that
they are
manually.
gone. They are gone. They are gone. They're completely gone. Maybe in next 6 months or so, people will still do it. But I believe in a year, there's a lot of things that we do currently will not be applicable. As a developer, especially the developer skill, they are changing drastically.
I really like that. I definitely we should have another episode just dedicated to actually probably a series of just developer workflow. How do you really leverage all this stuff? I'd love to see what you and some of your colleagues what your workflow is and how are you using this. Are you using Code Whisperer or what do you use?
We use different type of models. So primarily, I use one IDE which is called Cursor. So it has been a extension of VS Code, but it is written from the perspective of Gen AI from the beginning. So rather than adding few plugins, it has a Gen AI workflow embedded into the system itself. So there's a lot of things that you can do very natively in that product. So it makes the life extremely easy, starting with a new code or to write something very fast.
Cursor. The AI first code editor, cursor.so. Oh, cool.
And
Oh, I love that.
the one thing that I liked about it is that it can integrate with any, it's a free software out of the box. And you can integrate it to your own OpenAI system by providing OpenAI keys. So you need not to worry about that your code will go outside your organization to uh, some other third-party businesses. You need not to worry about all that. You can just attach your own API keys, your own Claude keys, whatever model you prefer. You can use that out.
I'm going to share my screen for a second. This is I have a similar workflow, much older editor. Let me see. Stop screen. Let's share a screen here. I was working on this yesterday. Actually, I was working on some automation. So I have this is Emacs, and I've got some code which is posting to social media, and I needed some Python code to change a date from one format to the other. And so I would, within org mode, I can do, let's see, let's start a new block. I could say, give me a Python function which takes a ISO 8601 date and returns it in epic time in milliseconds. Right, and then I hit my keyboard shortcut. It's contacting OpenAI with my API key. It is writing this out in Markdown for me. And then I've got my Python file that I'm working for over here, and I just copy paste it. I'd imagine Cursor is probably a bit more tightly integrated.
Yes. So it will directly post the code inside the location.
Okay, so that's similar to Code Whisperer, where you can write it as a comment.
Yes. Yes.
Cool. I'll have to have a look at that. I mean, I think for me, the Emacs shortcuts are kind of burned into my brain, but I definitely want to see the learnings and, of course, see if I can customize something to put into my Emacs profile. I think it would be kind of cool. So thanks for putting that on the radar. Let's see. I'll put a link to that as well. And I hopefully Code Whisperer will open up their API. I know there's extensions for VS Code, but hopefully they open up their API, which I'm sure they will at some point.
Yes, they will, because AWS, Amazon in entirety is API first company. So they like to create the APIs and then make it enable others to build over it.
Yeah, exactly. So yeah, it's only a matter of time.
Yes.
Well, should we get to the hacking part of this hackathon? Let's pick up where we left off last week. So to summarize, last week we had taken a selection of transcripts from previous episode of AWS Made Easy. I think we did 2 of the first episodes, and then we trained a model. So to make sure I'm using the vocabulary correctly. So we started with a foundation model, and then we didn't train a custom model, right? We added embeddings for the two of the transcripts that we then wanted the model to use as context in making predictions. Is that right?
Let me phrase it out in a separate word. So there is a technique which we use, which is called RAG technique. So the problem with which we started is that the token size is very limited in all of these LLM models. So they have a very short memory. So they are like goldfish in this kind. So they can only remember few words. So but our transcripts, and most of the time our data is in maybe MBs or even in GBs, which is very hard to put into the same limited 8,000 words, 8,000 tokens, or even if it is a bigger LLM, 16K or 13K, but still it will be not be able to do. So we use a technique called RAG. RAG stands for Retrieval Augmented Generation. So the first retrieval represents that I am going to retrieve a document. The second A for augmented, which is I will augment my LLM call with the limited amount of data that I have fetched. And G stands for generation. Now I will ask LLM to generate the message. So it's like think of it like that. There is a ton of data that is stored on Google, but when you ask, I want to learn more about AWS Bedrock, then you will get a very small set of results. There is a lot of data that is not associated with the request that you have made. So this technique allows you to filter all those data that is not associated with the request that you are making, and limit it to a very small amount which you are only concerned with. So maybe 1 MB data out of 1 GB, or even bigger sizes. And that process is extremely fast. And once we have that smaller amount of data, then we do LLM calls on that to get our results.
Yeah. Okay. So it's almost like the context that the
Yes.
question. So okay, here's an example, right? If you go to your doctor, right? And your doctor knows you, but then they see lots of patients, so they pull up their medical record of you. They look through all your history. Here's your charts, blah blah blah, and that's kind of like a summarized. That's the context in which they look at you. Your medical record.
Yes.
And so they don't need to know your whole life story, your best friend when you were 7 years old. They can uh, they can boil that down to just this bit of context that's relevant for the discussion that's about to happen.
Yes.
Cool. All right, I like that way of thinking about it. So this is the context, because we can't type out our entire life story into every single AI prompt that we have, because there's that limit of what we
Yes.
call tokens, right? So we can't
Yes.
say load my life story into your memory so I can ask you, what restaurant should I eat at today, right? You don't need my whole life to know that. You need to know some preferences over the last couple of weeks.
Yes, definitely. That's a actually very apt way to represent it. That in the life story perspective. So we have lived for so many years that there is a ton of data that is associated with our information. But to answer a particular set of questions, you do not need those all kind of things that we do. You only need that certain amount of operations. So yeah, that's a very apt way to represent it.
And so with the foundation models, the idea is there's a certain amount of knowledge already there, right? Before we even
Yes.
trained it, it knows what
Yes.
AWS is. Well, not just that,
Yes.
but just a level back, it understands the structure of questions and answers.
Yes.
It knows what AWS is. Um, I'm using knows with air quotes, right? What does it know? How do you that? That's a very philosophical question, but there's information embedded inside of it. With kind of general knowledge, and a lot of general knowledge. That's where they have billions of parameters. But then thinking about, okay, I want it to have an additional specific bit of knowledge, which are these transcripts from these couple of episodes. And so then
Yes.
this is what has been turned into this. That's what this RAG approach is allowing us to do, is have this distilled
Yes.
bit of context that we can then add on top of the general knowledge of the particular model that we're using.
Definitely. So if you have to ask a question which is related to its own knowledge, this reg required is not required, because that particular knowledge or information is already embedded in the model. It is required when you want to, as the word says, augment it. Every word, it is a very apt term that they have used, retrieval augmented generation. The second word, augmentation, is you are augmenting the knowledge of LLM after retrieving from a bigger set of chunks, and then you are asking LLM to generate it out. So it's a very apt term to represent this concept.
Awesome. Well, should we put your code up on screen? We can show where we got to last week with just a handful of lines of code, and then let's see if we can ask, kind of show where we got to last week, ask some questions of the model, and then maybe let's try and switch the context a little bit to a further episode. I think we had started with episodes 1 and 2. Let's try and switch that context to one of the episodes that I found. I found them all really valuable. But there's some specific questions that I'd like to ask one of our guests, Rick Ox, who he owns Compute Optimizer and a lot of the optimization toolkits. He came online for episode 66, and plus we did a bonus feature on GPU compute optimization. We're calling that episode 66 and a half. So I want to see if we can ask some specific compute optimizer questions that and then when we add those 2 episode transcripts to the model to see what happens. All right, I think, is your screen ready?
Give me a moment. I will just spawn up the container. And then
No problem. While you're doing that, I'm going to put those episode links in the chat as well. Those are really helpful episodes. Let's see. I'll put in this. Okay, here we go in our comments. I'll put that right there. So go check out episode 66. That is in the links in the chat, and then also episode 66 and a half, where Rick joined us to talk about compute optimizer for GPUs. That one was really interesting. One thing I learned about that is that when you're optimizing for a GPU, your optimal usage is like 99.9%. That's when you're getting great value. When you're optimizing for CPU, you want 40, 50%. That would be great. And he had told us that a lot of, like, the average EC2 usage. Actually, Harsh, what do you think the average CPU utilization across like all of EC2 is?
I assume it is less than 10%,
Yeah.
around that range.
He said it was about 6, and that when customers got to 10% or 15%, that was like a major accomplishment. So yeah, it was really neat to hear from him how they do all the analytics around instance retyping, and then they, through Compute Optimizer, you can make an API request and say, hey, what size should this instance be? And then use that to automatically retype or resize.
Yes. Maybe this GPU CPU thing, since you have brought it to the topic, I believe it is also a matter of the way we are using these in the cloud. Most of the CPU things are being used in a synchronous manner or user facing endpoints. So at that time, we want some kind of vacant compute efficiency available. So to take care the dynamic loads and all those stuff.
Mm-hmm.
However, in case of the GPU, most of its uses lies behind the models where we are doing it on a queue-based fashion. So we are putting out something in the queue, and then GPU is operating on that particular request. So if you look at from a different perspective, most of the machines comes with the GPU inbuilt in, and if you look at their average utilization of the GPU, it will go less than 10%. So they are just wasting out most of the GPU unit that is available to them.
Yeah, that's a really good point, right? In addition to having different physical characteristics, they also have very different use cases. So if you had a CPU that was at 99%, unless you're doing some kind of simulation, right? If it's at 99% and then a request comes in, well, it's going to, your system's going to fall over. It can't handle it at that point. Whereas GPU, we've lined up a big queue of work. It's inverting a big matrix or doing a big multiplication, and it's okay that it's pegged because we want to be getting full use out of that GPU. All right. Well, let's see. Are we ready to check out the app?
Yes, we are nearly ready. I just need to set up the credentials, clear my screen, not to leak
No
them.
problem. That is,
and then we can start.
We need to get some Tamper Monkey scripts. I always inspect the element and change a bunch of things manually just to make sure, right? You don't want to share your screen and all of a sudden have an API key that's public and you have to go change that.
Yeah. So predominantly we are using private secrets, but for the security purpose, anyway.
Yeah.
Okay. We are ready. I can start sharing my screen.
Okay.
Let's start with the questions first. So this is our same Q&A with Rahul bot that we have prepared in our last call. Now this is tuned with the new request that Stephen has posted out along those 2 episodes. So now it has the intelligence of these 2 things available in its system.
So episode 66 and 66.5 that has that context. I wonder, let's see, or maybe we could ask the question.
Sure.
What is different, or let's see, what is the target GPU usage in percent. Yeah, that's. I wonder if that's well phrased as a question.
Yeah, the one of the thing that I like about LLMs is if they are good Q&A bot, then they can understand a lot of meta things or a lot of the way we represent these things. Even with a big English, wrong grammar, they can still answer out.
Wow, that's cool. Look at that. Okay, the speaker indicates that for ML workloads, high GPU utilization is expected and desired. For other types of workloads, like video encoding or graphics rendering, the utilization may fluctuate more in the 50 to 60% range. Those are great points. For other workloads, utilization varies more based on the specific task. There's no clear target utilization percentage given.
That's also a very good point because it depends on the workload. If you're running on models, if you're running on rendering tasks, it may differ.
Okay, can we ask what is that discussion we were just having about CPU utilization on EC2? Where are most users of EC2 in their optimization journey? How much room is there for optimizing instances? And so I'm having trouble phrasing the question in a really good way, but like you said, that doesn't even matter because it's trained
Yeah,
on
it can
dopes like
impact the
me.
answer. It can impact the answer, but our ideal AI solution should not be impacted. So that's the one thing that I am very excited about the future direction of this. That you will not need any prompt engineering. You will not need anything. The future AIs would be able to understand whatever way you speak, whether it is good or not. They will be able to drive that intent.
That it is pretty cool. Although it's interesting thinking that we are also shifting, right? I mean, our language patterns shift over time as well, and I see that with the younger kids who are like ordering the Alexa around, right? And my younger kids and they have a certain tone of voice that they use with Alexa, and so Alexa's learning from them, but they're also training themselves to talk to it, right? And so we're also kind of training ourselves to speak to AI in a way that's clear, and we think it's going to be AI is coming to us, but we're also coming towards it a little bit. All right,
Yeah.
so let's see how the answer that it gave us. Okay, EC2 is the primary compute service that Compute Optimizer looks to optimize. There's a lot of room for right sizing, even at the high risk level recommended by Compute Optimizer. Oh, that was a good point. Okay, memory metrics unlocks even more potential. I'm glad it brought that up. In talking with Rick, he said that was one of the most important ones is enable memory. Because otherwise, that's what unlocks a huge amount of potential.
Yes.
Let's see. Right sizing instances allows customers to get better efficiency elasticity without re-architecting to support containers or serverless. That's another one of those really good salient points that we made.
Definitely.
It's actually one of the talks we advertise. We think of elasticity as either EC2 where it's totally fixed or serverless where it's totally elastic. But EC2 is
Yes.
very elastic in and of itself. You don't need to go full serverless. You can resize, you can retype, you can turn instances on and off, you can pause them. You could treat it like a very elastic resource. It's not as elastic as Lambda, but you could highly optimize. You don't have to just start 100 instances because it's a nice round number and just leave them on.
Yes, yes. You have actually pointed out a very, very good point. During my graduation year, it's around 2016 when this Docker thing was completely new, and we are building things in our local college cloud. So the one thing that we have observed is at that point of time, my lingo is EC2 is very, very dynamic, very, very elastic, very, very flexible. But over the time, with the advent of containerization technology and with the advent of a lot of new stuff on the cloud, it leads to a situation where there are more elastic solutions that are available, like serverless, which are fully elastic. So they lead to a situation where poor EC2 is being called nearly equivalent to on-premise solutions, which is quite a big misunderstanding. You have a full control on what size of instance do you want, how long do you want, how many do you want. You can spawn them anytime, you can destroy them anytime, you can increase their size, decrease their size. Everything is controllable, but because of better options, we put them into the same bucket as on premise.
I remember, and do you remember when EC2 they used to have hourly billing, where
Yes.
if you used 1 hour and 1 minute, you're like, oh, okay, I've paid for another hour at this point. I'll just leave it on for another 58 minutes, and I'll remember to shut it off at 1 hour and 59 minutes.
Yes.
Like when you're using EC2 as a developer workstation. But now it's much more is it to the second or to the minute? It's very granular.
Yes.
And so you have this it both in price and in terms of, like you said, it's very quick to retype or resize an instance. Yeah, you could treat it as a very flexible resource. Even though there are higher levels, it's still, as the name says, elastic compute cloud.
Yes. Definitely.
Here's another question I want to ask it. Okay, this one is a bit more nuanced. So what are the environmental benefits of Compute Optimizer? Because Rick had touched on this about as you optimize, you're also using less electricity, which is less power, which is more green. So I want to see if it picks this up. There we go. Okay. Based on the answer provided, Compute Optimizer helps optimize the usage of compute resources like EC2 instances and GPUs. By optimizing resource usage, Compute Optimizer can help reduce the amount of energy and power needed to run workloads. That's cool. I'm going to ping Rick on LinkedIn. See. We are using Can we copy and paste? Can you copy and paste that answer? That's really cool.
Sure, definitely.
Thanks. Let's put that in the comments. I think you have access to the comments? Oh, there we go. Oh, there it is. Yep, that's it. Perfect. If you can put it, for some reason, StreamYard's connection to LinkedIn isn't as good. If you could put that in the other chat window, then I'll paste it into the LinkedIn chat.
Okay, I think that is not available to you, but what I can do is just give me a moment. I will copy this entire thing and post it on the private chat. Maybe you can
perfect.
do it.
Yeah,
it is not copying the whole. I think it's missed after for the.
Yeah, I see the. I'll just put the first couple of paragraphs. That's pretty cool. The first couple of sentences.
Yes. Now it is complete.
That's cool. All right, that's exciting. All right, can we look at the code behind this? Just wanted to give an example to the audience of how straightforward this is.
Yes. There's a very beautiful thing that we can look into it. I have enabled the logging of the system. So it will now give me the entire process, how things has happened, what is the text that it has retrieved, what is the text that it has augmented, and what is the text that it is generated in all those three different steps. So when I ask this question, what are the environmental benefits of the compute optimizer, there is a lot of context, and it identifies that this is the paragraph in all of your transcripts that talk about this. After that, it creates a prompt for the LangChain, and it generates this small thing. So the idea, you can see how it is happening. We are identifying first the raw data, raw context, the same thing that we have talked about, the word context. So we identify the raw context from our transcripts and then do this.
Got it. Okay. So could we scroll up in the code a little bit? I want to see that how you're using the LangChain part.
Sure. So it's a very small code. So there is not much on the code base side. There are few imports. I think imports are more than the actual code of line. So we initialize the Bedrock clients. We get the Bedrock embeddings from their Titan models. Titan is a model from the Amazon. Then these are the 4 different functions, 3 different types of way to load the data. LangChain provides you tons of ways. It can lead from YouTube video. Yeah. So that's also a very interesting thing that I found from our transcripts idea, that LangChain has a YouTube transcriber. So you give him the link of a YouTube video and it will automatically ingest it out, convert it into its transcript, and then make it available as a solution. So if you have a good podcast on the YouTube that you want to watch, you want to make it as a Q&A session, or even the list of the learning videos that you have identified, and then you want to make a Q&A bot over it, you can do it very easily.
Okay. So these text loader, directory loader, CSV loader. So there's a YouTube loader that gets a URL, and then behind the scenes that is downloading the video, and then it's downloading the video, extracting or creating the embeddings for that. That's really wow. Okay. Well, I wonder. So these transcripts were generated with Transcribe, and I didn't correct them in any way.
Yes.
I wonder if this might do a better job at extracting the meaning.
Yes. If there are small grammatical mistakes, like for example, in our case, GPU is not combined GPU, but it is GP space U, but it can identify it that you are talking about GPU. So even though there will be mistakes of the, is, then, the, many grammatical mistakes, LLM will autocorrect it out.
Okay, so here's a question. So say if we did a podcast and the whole thing we were being sarcastic and satirical, and the tone that we were using was very satirical. Now, if we generated a transcript of that, it would mean the opposite of whatever we were saying. But if we were saying like, yeah, on-prem is so much better, I really like buying hardware. If we did it as a video embedding, would it figure out that that's not actually what I meant, that I'm using sarcasm? So like, if you then queried, what does Steven actually believe about on-prem?
It will probably not. So
I wonder. Well, we'd have to. I
let's
guess what I'm
do a
trying to
small
see is.
test. Let's try it out. It's simple. It will not that be hard. Let me create a pseudo transcripts. Let's call it our satire transcript. TXT, and let me replace my. Let's write whatever satire you want. Stephen said, I like. Sorry, have I spelled your name correct?
Yeah, it's fine. En. It's PHEN.
En, that's correct. Yeah. Stephen said, I like on-premise solutions better. I like buying hardware. Maybe it will be able to do it. I like spending my money on idle machines. They I cannot remove after some amount after my uses, something like that, right? And let's train our model. Let's add this in our retrieval pipeline. Set a transcript, zoom it out, restart our system. Great. Now ask, are on-premise better? Solutions better. Let me reshare my screen to this. Solutions better. Let's try it out. Yeah, it is able to identify that it's your own personal preferences.
So I guess there's this famous moment in I guess the first televised presidential debate between Nixon and JFK, and the people who listened on the radio thought that Nixon did better, but the people who watched it, they saw that Nixon was really nervous, he was sweating, he was not. They thought that JFK had won the debate. And so I wonder if we could actually, that would be another experiment for another day, is to actually look at the transcript to kind of emulate the radio experience versus do the YouTube ingest and ask the same set of questions and see, kind of work out what additional context is being brought in through the video.
Yes. Currently, I believe even in the YouTube context, they are doing only transcribe.
Okay, so it's just
so they are only handling transcript. But that's a very good point that you have raised out. So let's say in the video we have more cues around it, right? So I can add these cues in my transcript. So Stephen said this, and then I will add a visual cue here, and we can have a separate model. I think GPT-4 is now available with image prompts. So you can provide it an image and it can drive out visual cues from it. So let's say we have a separate model which identifies these visual cues. Stephen was laughing while saying this. That is my visual cue for this audio script. And now my transcript, which was written in pure text, will also contain some visual elements, not as the image, but their description.
Okay, so in a future version of this visual cue is going to be frame by frame, right?
Yes.
And so okay, all right. That oh, it's an exciting time. That's really neat. To say, okay, Stephen, I could see it in a future one. It'll say Stephen, laughed sarcastically and used air quotes when saying this, right? And it will know, okay, I actually meant the opposite of what I said.
So even with just laughing, I think it can understood a lot. Let's see.
Oh, okay. Look at that. Based on the context provided, it seems Stephen was being sarcastic when he said he liked absolutely. I want to screenshot this. This is good. This is cool. Great. Thank you for showing that. That's really interesting. This okay, so you can actually add a visual cue, and then so we can see later there will be stacks of models that are extracting this visual cue.
Yes.
Wow, okay. We're just looking at the time. I wanted to keep it to not too much longer, but just thinking through what would be the next step for operationalizing this. So I'd imagine we could wrap this up in a Lambda function, which is an API endpoint, right? Where you would have a question, and then that Lambda function would basically embed the code. Well, I guess that's basically what your Streamlit app is doing. Or you could just publish the Streamlit app, right? That's the easiest way.
Yes. Stephen, am I audible?
Yeah, that's fine.
Okay, great. So Streamlit is okay for deploying a small demo loads or a testing load, or maybe for a beta testing type thing. In
Mhm.
production, you will need a lot of other elements, and those elements will be uh, like caching. You will need to enable caches. You don't want to run LLM on the same questions again and again. You want the safe error messages. If user has asked something which was not supported there, there should be some safety net there. And if Bedrock is not available at that point of time, it has code in the rate limiting errors, then there should be some kind of a message saying to user, please retry in this few minutes, or we need to connect to more instances, something like that. So when you go into a production workloads, there is a lot of things that you need to do uh, out of the natural flow. However, with the help of the LangChain, we are able to implement the core business logic, which can then easily be shipped into AWS Lambda. 90% of the scaling things, checking out if we are not going under DDoS, checking out if the user is authenticated, and if you attach it to the cloud front, you can also get a caching out of the box. So AWS has a whole set of arsenal available to do all of these kinds of production things. So it's extremely easy to shift this particular stuff into a proper API endpoint where user can go and try.
And at that point, if you really wanted to, you could do something like Amplify, where you used Cognito to have a user sign up, because maybe we want users to sign up for this very valuable oracle of information, or just so you could use Cognito for that, and then you could use the Amplify front end framework, and then call this Lambda function on the back end, and then you said CloudFront for the caching. That's really neat.
Yes.
So this isn't a multi-month project or even multi-week project. This is something that's pretty straightforward.
Yes, definitely. Especially when we talk about serverless, especially about the AWS has designed its services, they have provided. I remember the last reInvent talk, in which one of the talk was how to ship your products very fast, or how to do your POC very fast using AWS serverless. So they were trying to reduce what is happening over months in weeks using serverless solutions. So serverless enables the deployment, which can be pretty solid production for your varied loads out of the box.
Let's see. Was that? Let's see. There's accelerating innovation with serverless.
Yes.
Okay. I will put that in the comments. Serverless is really neat. I really like the huge Lambda fan outs you can now do, where if you have a big parallel batch job, you can start
Yes.
within a step function. You can say, I want several thousand Lambda functions to run in parallel, and that's so much
Yes.
easier than starting a cluster and pulling from. It's much easier to just say, okay, just use Lambda. That's a
Yes.
very easy way. And then you have an upper bound on the amount of time a particular function can compute. I have
Yes.
a friend who's making a kind of a game or a self-study platform for code, and they want to have a way of executing code that the users submit just little pieces of code that only have to run for at most a second. And Lambda can be a really useful way to do that, because that way you have control. Okay, I could put a timeout on this Lambda function. They have an upper bound on the amount of money it can spend per invocation. That's
Yes.
Lambda's great. I like Lambda a lot.
Yes. And Lambda is a very powerful compute service, but what we can also look at from a perspective like this, compute in isolation is not that useful. But if you combine compute with all other kind of meta AWS services that are there, for example, you name the step functions, there are Event Bridge, there is CloudFront, there is API Gateway, there is S3 bucket for kind of a serverless storage, there is kind of a huge arsenal of databases that also supports serverless services. So it's a complete environment in which nearly every requirement of your application can be served in in a serverless fashion.
Well, I have to mention AWS SAM, right? That's even a very, it's like CloudFormation, but it's like a subset of CloudFormation things. SAM is the serverless application model. I'll put a link to that in the chat. I really like AWS SAM. You can, if you want a Lambda, just you want a quick couple bits of YAML, and probably you just get this Code Whisperer or ChatGPT to write the YAML for you. But if you want a Lambda function to just exist, and say you want a Lambda function that has write access to a certain S3 bucket, you can use what's called a SAM connector, and that will handle. You don't have to write custom IAM policies for everything anymore. You can just say, I want this Lambda to talk to this bucket, and it will work out the permissions behind the scenes. There's a lot of really great ergonomics of SAM. And another one that I love is Lambda function URLs. So that way, if you just want a function to exist on the internet, you don't have to deal with API gateway and all that other stuff. Just say, give me a Lambda function with a public URL.
Yes, but be careful with that part. If a DDoS happens there will be a lot of big budget coming out.
That is a good point. Is there a way to enable DDoS protection? I guess you could do.
Yes, there are ways to do it. AWS again provides a lot of guns in its arsenal to stop these DDoS attacks. So there are multiple ways in which you can do it. In the Lambda, you can limit the concurrency, maximum concurrency that you can achieve on your system, and then later you can also have the. So it is very recommended that if you're opening it to the outside world, we use API gateway, but AWS also provides many things out of the box for these kind of things. We need to configure it better. That's very important.
Yeah, that's a cool. I think we have a lot of topics for other ones. Well, let's look into a future hackathon where we put this into production, and then also let's figure out maybe at some point we can do a trade model on the whole corpus of episodes. I need to double check to make sure that with each transcript, each speaker is labeled, so we can say, differentiate the different guests from Rahul and from myself. But yeah, I think there's a lot of potential we can do with this, and I think it'd be a fun thing to have public on the CloudFix AWS Made Easy site. You can ask a question of the stream. I think that's a really fun idea.
Yes, definitely.
And we'll have to test it to make sure it. Well, I think what I'll do is we'll wire up a Slack bot, so as people ask questions, I can monitor the answers it's giving to make sure it doesn't somehow hallucinate some terrible advice.
Yes, definitely. Possibilities are endless. With the way the LLM allows you to connect your interfaces with any other tool, that's astounding. And even building a Slack bot for it, building a Discord bot for it, for Discord fans, and even building any other bot is extremely trivial with the LangChain support.
Well, Harsh, this has been a really, really fun stream. I've learned a lot, and it's been really neat to see. I love that visual cues. I'm going to experiment with that. So thank you for sharing your knowledge and experience with us, and we'd love to have you back another time to do another to do part 3. I think it's going to be a fun series. This has been really good.
Thanks, Stefan.
And thanks for sharing your Friday evening with us. And thank you to the audience for being here. We really appreciate your participation. And we will see you again next time.
Sure. Thanks, Stefan.
All right. Audience. Have a good one.
Bye.
Some tools just find AWS cost savings and make you do all the work. Visualizing cost opportunities is great, but that's not enough. CloudFix, on the other hand, actually delivers those savings for you. And you don't need to worry because CloudFix fixers are AWS recommended and easy to use. It's the only tool that fixes cost savings opportunities and doesn't just find them. It's the easiest way to save money on AWS. It's all 100% automatic and risk-free. And the best part is that it works non-stop. See for yourself. Click on the button to get a free demonstration of CloudFix and stop overspending.